Today we'll be talking about the interior and exterior angles of polygons. Vocabulary you should know coming into this lesson would be the difference between a concave and a convex polygon and determining which angles are interior and which angles are exterior. In this lesson, you'll learn what a diagonal is, the difference between an equilateral and equiangular polygon, and the definition of a regular polygon. A diagonal is a segment that joins two non-consecutive vertices. For instance, if I start here at vertex B, I can draw a diagonal that goes from B to D. I can also draw a diagonal that goes from B to E. If you start drawing all the diagonals of a convex pentagon, we end up with a total of 5 diagonals. How do we end up with 5 diagonals? Well, if you take the 5 vertices, and we have 2 diagonals from each vertice, if you look, the diagonal that goes from B to D, or B to E, we count from B to E, but we also count it again when we drew it from E to B. So since we doubled up on each diagonal, we're going to divide that number by 2, and a pentagon not only has 5 sides, but it also has 5 diagonals. The interior angle theorem of polygons says that if you have a convex polygon and we have the number of sides n, to find the sum of the interior angles, we're going to take n minus 2 times 180. Where does the n minus 2 come from? The n minus 2 comes from the fact that if you take one vertex and you draw all the diagonals from one vertex, we form triangles. In this particular case, we have a hexagon with 6 sides, and we have 4 triangles. So 6 minus 2 times 180. So we have 4 triangles, each with a sum of 180 degrees, and 4 times 180 is 720 degrees. How come we only have 4 triangles even though we have a hexagon? If you look, this side here and this side here, you're connecting one vertex to another vertex, but it's actually not a diagonal. That's considered to be a side. Therefore, we always subtract out the 2 sides right next to the vertex that we draw the diagonals from. Example number 1, find the sum of the interior angles of the polygon. So the first thing that we have to do is we have to determine the number of sides our polygon has. So if we start counting here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have a decagon with 10 sides. If we think of the sum of the interior angles, and we use our formula, n minus 2 times 180, we have 10 sides minus 2 times 180 degrees. If you continue with the math, and yes, you can use your calculator, you will have 8 times 180 degrees. And if you take the time to put that in your calculator, you end up with 1,440 degrees. So that says if you take all the interior angles of this polygon, every single one of these angles, and you add them up, you will come up with an angle total of 1,440. Looking at example 2. If the sum of the interior angles of a convex polygon is 1,800 degrees, classify the polygon by the number of sides. So if we think about our formula says that the sum of the interior angles of any polygon is n minus 2 times 180 degrees. In this particular problem, they told us what the sum was, so I'm going to put the sum in. At this point, I want you to hit pause, and I want you to do the algebra, and I want you to determine the number of sides and classify the polygon. If you have done your math correctly, you could have done this one of 2 ways. I'm going to divide by 180, so I get 10 equals n minus 2 because my 180s cancel out. If I add 2 to each side, I have n equals 12. So technically, we call this a dodecagon, a polygon with 12 sides. The corollary to the polygon interior angles theorem says the sum of the measures of the interior angle of any quadrilateral is 360. It does not matter if you draw a kite, a rhombus, or a rectangle. If we take any of these quadrilaterals and draw the diagonal from a single vertex, we always get 2 triangles. So no matter what, a convex quadrilateral has 2 triangles, and if you take 2 triangles formed by the diagonals times 180 degrees, that gives us a total of 360 degrees. We talked last semester about equilateral and equiangular. An equilateral polygon is a polygon with all sides congruent. An equiangular polygon is a polygon with all angles congruent. If an equilateral polygon married an equiangular polygon, you would have a regular polygon. Okay, so a regular polygon has all angles congruent and all sides also congruent. I want you to take a minute and think. Is it possible for a polygon to be equilateral and not equiangular? And could a polygon be equiangular and not equilateral? Take a minute, hit pause, answer these in your notes, and explain your reasoning. If we talk about the exterior angle polygons, they are way easier than the interior. They always, under every single circumstance, have an exterior angle sum of 360 degrees. So if we look at this picture and we add angle 1 to angle 2 to angle 3 to angle 4 to angle 5, and we add all those angles up, the sum is going to be 360. It does not matter if we have a quadrilateral, a pentagon, a decagon, a 20-sided figure, or a 50-sided figure. Example 3. If we wanted to find the value of x in a diagram, I look at the 4 angles that I'm given and I have determined that they're exterior angles, which tells me that they sum 360 degrees. If I set up the algebraic equation, I have 4 angles, 2x, x, 67, and 89, and they sum 360 degrees. This is a required step in working this problem. From here, I want you to hit pause, and I want you to do the algebra to determine the value of x. After showing your work, you should have determined that the value of x is 68. Sometimes they will ask us to find the measure of each interior and each exterior angle. So basically what we will do is we will take the sum divided by the total number of angles. So if we have a decagon, we are going to use the formula 10 minus 2 times 180. That will give me the sum of all the interior angles. And then I'm going to divide by the total number of angles in my polygon. Because this polygon is regular, that tells me that all the angles are the same, and that's what allows me to use this formula. You will enter this into your calculator, and that will give you your answer. So take the time to hit pause and to plug this into your calculator. So each interior angle will equal 144 degrees. If we want to find the measure of each exterior angle, we will take the sum of the exterior angles and divide by the number of angles. So for instance, we again have a decagon. The sum of the exterior angles of any figure is 360 degrees. A decagon has 10 angles. And if we do the math, 360 degrees divided by 10 angles will tell you that each angle is 36 degrees. I want you to try the following problem on your own, show your work, and find the value of x, and we will talk about it when you get to class tomorrow. Have a great night.